Hi, today we will discuss the noise in the work environment. Sound is very important because it helps human beings communicate with each other and receive information between each other. So, sound is very important as well in terms of providing warning, such as when you hear the fire alarm, and also it provides enjoyment when you hear music. In addition to these joyful and useful and pleasurable sounds, there is noise. Noise is defined as the unwanted or extraneous sound. The workplace environment is full with equipment and machines that produce significant levels of noise. Every machine or tool or a compressor in a building is a potential source of noise. Noise is identified as one of the most annoying factors in the environment because it causes damage to the ear. And usually this is a long-range problem and sometimes it's permanent. Exposure to noise can cause several health effects ranging from insomnia and stress to hearing loss. Now, short-term exposure can cause a temporary loss of hearing, normally referred to as temporary threshold shift. But prolonged exposure to noise over a period of years usually causes permanent loss of hearing. Decibel, dB, is a dimensionless unit to express physical intensity or sound pressure levels. The reference point of hearing of a young person with good hearing is 0 dB, and the starting point of pain is 120 dB. In this graph, we will see incidence of hearing impairment for people of different ages exposed to varying levels of noise at work. At the y-axis, you will see the incidence of hearing impairment, and it's corresponding to the proportion of people at a certain given population who suffer significant hearing loss. Now, at the x-axis, you will see the level of dB. It shows the level of exposure to work-related noise, ranging from 0 to 110 dB. Now, each of these lines represent a rate for particular age group. So this line shows people who have an age ranging from 20 to 29 years. This line shows people who at the age of 30, ranging from 30 to 39. This line for 40 to 49, and this one for 50 to 59 years. So each of these lines describes the incidence rate for a particular age group as a function of the exposure level to noise. Now, as you can see in the graph, at each line for different ages, the proportion of people suffering hearing loss increases as the level of exposure to noise increases. So as the level of exposure to noise increases, people will suffer hearing loss more. You can see that older people had the greater percentages of damage at all levels of exposure. So you can see here at 80, you can see that older people had the highest percentage. At the 90, also the older people had higher percentages than the other ages. even when people were not working in loudy work environments, so in this range from 0 till 80, here we can say that this is an acceptable range of noise. Even at these ranges of noise, the older people had, we see here at 23% of the people had some hearing impairments. When I say the word impaired, this means that it means damaged. And the term hearing impaired is often used to describe people with any degree of hearing loss, from mild to profound, including those who are deaf. So it is 23% for older people when compared to 2% related to those who have an age between 20 and 29 years. So if I want to look at people who had jobs which exposed them to noise level of 90 dB, you can see that around 33% of older group, the hearing of those people in this group was impaired at a percentage of 33. And if I want to compare it to the youngest group here, it will be about 5%. At an exposure level of 100 dB, the proportions were around 56% for this age group, and it was about 14% for the youngest group. So at 105 dB, you can see that it is around 70% for the older group, and for the youngest group here, if you look here, you can see that it was around 20%. The sad thing is that the majority of older people working in noisy environment had a significant loss of hearing, and also younger people working in extremely noisy work conditions were suffering, let's say here it was around 20%. When I compare it to elder people who were working with not noisy environment, it was about 23%. So this is sad for young people who are losing their hearing at early ages when compared to other elder people who maintain their hearing 30 years more than them, with who were working with normal or non-noisy working environment. According to the World Health Organization, they determine the daily permissible noise level exposure. So here, for example, if you are exposed to sound level of 80 dB, you can be exposed to it for 25 hours in a row. Okay? If let's say you were exposed to sound level of 85 dB, then maximum you can be exposed for 8 hours, consecutive 8 hours per day to this 85 dB. And as the sound level increases, the time of exposure should be minimized. So they determined that the highest safe exposure level is 85 dB and for up to maximum of 8 hours per day. Now, if it was 100 dB, for example, this is the sound produced by the subway train, you can be exposed to this sound for only 15 minutes per day. So these are the recommendations of the World Health Organization. They also published some common sounds and their intensities. For example, the sound of a normal conversation is 60 dB. The heavy city traffic inside the car is 85. The sound of a hair dryer is 100. Shouting into the ear is 110, and so on. Now let's learn the mathematics related to adding decibels by using the following chart. You can see that here sometimes you are exposed to different sources of things that cause noise. What would be the total combined dB for these different sources? This can be calculated using this chart. For example, here we want to combine 80 and 75 dB. Let's say we have two machines. One produces 80 dB and the second produces 75 dB. So what would be the total dB that you're hearing? Now, what do? They subtract 80 minus 75, so the difference is 5 dB. Now, the 5 dB, we will look at the 5 here. This 5 intersects this curve, okay, at this point. This point is related to what? Let's see here. It's related to 1.2 dB. So what do? We add this value that we got from the chart, the 1.2 dB. We add it to the loudest sound, so we add it to 80. So the total will be 80 plus 1.2, so it will be 81.2 dB. Now, what if we have two machines that produce the same level of noise? Let's say both of them are 80. In this case, the difference is 0. 80 minus 80 is 0. So 0 will intersect the curve at this point. So the point of intersection is 3. So adding two equal sounds increases the SPL by 3 dB. If the sound difference is more than 10, you can see that here, let's say it's 13, and intersect the curve here, it's near to 0. So the contribution becomes negligible as the difference between the two sounds exceeds the 10 dB. Let's check this example together. Here we have a machine that has a sound intensity level of 80 dB and heard from a distance of 15 meters. We have an operator who is standing 15 meters from 4 of these machines. What SPL? SPL is the sound pressure level. What's the SPL that reaches his ears when the first machine is turned on? What is it when the second is turned on, the third, then all the 4 together? So the first machine has an SPL of 80 dB. When we turn on the second machine, then we have two machines that has 80 dB. So what's the difference between them? 80 minus 80 is 0. And as we said, when it's 0, you see here 0 intersecting here at 3, then we can add 3 dB. So the total will be 80 from the first machine, and this is the addition for the second machine. It will be 83 dB. Now the total of these two machines is 83 dB. What happens when we turn on the third machine? Now we will say that this is the difference between what we currently have, the 83, and the third machine that is 80. So the difference is 3. So what do? We go to the chart and look for number 3. Here is number 3. We look, where does it intersect the curve? It intersects the curve here. So this is related to what? This is related to 1.8 dB. So the new SPL will be the 83, okay, plus 1.8, it will be 84.8 dB. This is the total that we have till now. So we'll have to compare this number with the fourth machine that has an 80 dB. We subtract the values and we get 4.8. Now we look at the chart. This is the 4 and this is the 5. And you see this is the 4.2, 4, 6, and 8. So at 4.8 here, this is the point at which we intersect with the curve, and we look here, we see that it's related to the 1.2 dB. So we add the 1.2 to the 84.8 and we get a total of 86 dB. Now we all agree that noise can be very annoying because it greatly interferes with people's ability to communicate with each other. Now they have put a scale for determining the rate of annoyance. 1 as not annoying, 2 as lightly annoying, 3 moderately annoying, 4 quite annoying, and 5 extremely annoying. So they did several studies to study and to get the relationship between annoyance rating and noise level. So they got this equation by regression analysis. So it says that the annoying rating equals to minus 4.798 plus 0.106 dBA. So if I tell you, for example, that the noise level was 85 dBA, so what do? We put it in this equation, multiply the 85 dB by the 0.106 and then add it to the value here to get the annoyance rating. So here, what did we get? The rating was about 4.2, and if we remember the scale that we have set from 1 to 5, we can see that it is quite annoying. Now let's check some principles related to reducing noise. Principle 411 says that to reduce the noise level, you should reduce the noise level of the source itself. Of course, this is the best choice to start with. We need to check each machine and see the noise level. Can we make it more quieter by putting a silencer, for example, or identify why is it making this noise and see if we can change, make some design changes to minimize its noise. Or as the second principle suggests, enclose the source. Now, enclosing the machine sometimes makes the maintenance very difficult and may cause the machine to overheat. So before enclosing machines, we should check with the manufacturers to see if it's possible or if there are any downside to enclosing. We can also increase the distance between the source of the noise and people nearby by moving the machines away from personnel or moving the personnel away from the operation. You need to know that the noise level decreases as the distance between the source and the receiver increases. So for every doubling of distance, the sound level reduces by 6 dB. Okay, let's say, for example, we're moving from a distance of 1 meter to a distance of 2 meters. So the sound would decrease from 90 dB to 84 dB. But the next 6 dB that will be reduced, it will be reduced at the double distance. Okay, it was here 2 meters. Then at 4 meters, we will get a reduction of 6 dBs and so on. Principle 414 states that we should place sound absorbing and reflecting barriers in the noise path, because this absorbing material will help reduce the sound level energy, and the reflecting barriers will direct some of that energy away from the personal found, so that the sound wave will need to go to a larger distance before encountering with these people. Also, we can use some of the personal protective equipments, such as the earplugs and ear muffs, which are commonly used in loud environments to protect people from excessive exposure to noise. These earplugs are made out of soft materials, and when inserted into the ear, they reduce the sound significantly. The earplugs should fit without leaving any openings around the plug, and some of the earplugs have a retaining ring to make it easier to remove these earplugs. In some cases, the earmuffs are combined with other forms of personal protection, such as helmets or face shield. Sometimes it will also include some speakers and microphones. As an end, you need to know that there are some ergonomic issues associated with the use of hearing protection. One issue is that human heads and ears vary in size and shape, and this variability can make it difficult to fit certain people and may impact the effectiveness and comfort of these hearing protection. Another point is that wearing earplugs can interfere with the verbal communication and the ability to do the job. So these are some of the reasons given by workers who refuse to wear these hearing protection equipment. So that's it, and thank you for listening.